13.4, Compound Probability. A compound event is an event that is made up of two or more events. An independent event is when the occurrence of the event does not affect the occurrence of another event or other events. Dependent event is when the occurrence of an event does affect how another event occurs. So first thing we want to do is talk about how to identify independent and dependent events. So are the outcomes of each trial independent or dependent events? So for number one, choose a number. So is this event independent or dependent? So choosing a number tile from 12 tiles. Then you spin a spinner. So does the one event affect the other? In this case, these would be independent events. The number tile does not impact how you spin the spinner, or it doesn't impact the results you could get. Question 2, pick one card from a set of 15 sequentially numbered cards. Then without replacing the card, pick another. Well, in this case, these are dependent events. The first card you pull changes the probability of the type of card you'll choose the second time because you do not replace it. You're actually decreasing the number of cards to choose from. Three, selecting a letter tile, you do not replace it, then you select another letter tile. Well, just like the cards in part 2, we're changing the probability or the possible values in the second choice. So this is dependent again. The first event changes or affects how the second event occurs. And then roll a standard number cube, then flip a coin. These are two different objects, so they're not actually impacting each other. So independent. Probability of A and B. If A and B are independent events, then the probability of A and B, the A and B events occurring, is the probability of A times the probability of B. You will more frequently see this written instead of written out like this. You will probably see it written like this. Probability of A and the probability of B. So, a desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 12 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip without looking, what is the probability that you select a blue pen and a white paper clip? So we're looking for the probability of, in this case, blue, and the probability of a white paper clip. So in this case, the probability of blue, well, there's 6 blue pens out of a total of 14 total pens, times the probability of a white paper clip, which is there's 16 white paper clips out of 40 total paper clips. And so now we would multiply these together, so it helps to remember some of our multiplication rules for fractions. So if I want, I can go ahead and kind of reduce these. So here I've got 3 over 7 times 2 over 5. And then with fractions, you'll multiply straight across. So we've got 6 over 35. So your probability is 6 over 35, or we can change this to 0.171, or right around 17.1% is your probability for this event occurring. So this is the probability that you will choose a blue pen and a white paper clip. Question 2, you roll a standard number cube and spin the spinner at the right. What is the probability that you will roll a number less than 3 and the spinner lands on a vowel? So we're looking for the probability of less than 3. And we're also looking for the probability of a vowel. So we'll do these separately and then bring them together on the right here. So probability of less than 3. Well, the only numbers that I can think of that are less than 3 would be 2 and 1. So that's 2 out of 6, or in this case, 1/3. And then vowels in this particular spinner would just be 1/4. So now you bring this together. We're looking for the probability of less than 3 and the probability of a vowel. So in this case, we're looking at 1/3 times 1/4, which is going to give us 1/12. So the probability is 1 out of 12. And remember, you can represent probability as a fraction, a decimal, or a percent in this case. Question 3. You select a letter of the alphabet and choose a digit from 0 to 9. What is the probability that you select a consonant and a number greater than 3? So the probability of a consonant and the probability of a number greater than 3. Well, in this case, there are 21 consonants in the alphabet out of 26. Greater than 3, well, from 0 to 9, there are 6 numbers greater than 3 out of the 10 total numbers, which we can reduce down to 3/5. So right now we're looking at, these are our two probabilities that we need to bring together. So the probability of the consonant and the probability of a number greater than 3 at the same time means we're going to multiply 21 over 26 times 3/5, which in this case is going to give us 63 over 130. Mutually exclusive events are events that cannot occur or happen at the same time. So the probability of mutually exclusive events. If A and B are mutually exclusive events, then the probability of A and B equals 0, meaning they can't occur at the same time. Therefore, the probability of A or B equals the probability of A plus the probability of B. When they write this, they're also, one of the ways they write, instead of writing or here, probability of A or B, they are known to write it as a union B here, like this, the probability of A or B. So keep that in mind when you see this on worksheets and tests, that this statement is also written like this. Question 1. Student athletes at a local high school may participate in only one sport each session. During the fall season, 28% of student athletes play basketball, and 24 are on the swim team. What is the probability that a randomly selected student plays basketball or is on the swim team? So here we're looking for the probability of basketball or swim. So remember, this is where they're mutually exclusive. A student can't do both sports in this case. So we're looking for the probability of basketball plus the probability of swim. In this case, that means we're going to take the 28% chance you have of playing basketball plus the 24% chance of the swim team choice, and you get a probability of 52% is the likelihood that either they play basketball or they're on the swim team. In the spring season, 15% of athletes play baseball, 23 are on the track team. What is the probability of an athlete either playing baseball or being on the track team? So very similar to the last problem, we're going to have the probability of, we'll say baseball, with the probability of track. So we need to find the probability of baseball, which they gave us, plus the probability that a student could run track, and we'll bring those together. So we've got 15% plus 23% gives us a probability of 38%. Overlapping events are events that have outcomes in common. And so when we try to calculate overlapping events, we calculate for each event And then we have to take away the part that they overlapped because we would be counting it twice. So the probability of an overlapping event, if A and B are overlapping events, then the probability of A or B when they're overlapping is the probability of A plus B minus the probability of A and B occurring at the same time. So we have to take into account their individual probabilities and then take away any overlapping situations where it could occur. So let's look at question 1. What is the probability of rolling either an even number or a multiple of 3 when rolling a standard dice? So we're looking for the probability of even or in this case a probability of I'm going to say multiple of 3. So we're looking for the probability of even plus the probability of multiple of 3, but then we have to take away the probability of evened and the probability of evened and the probability of a multiple of 3 occurring at the same time. So the probability of rolling an even number on a standard number die, that's just 3 out of 6. That'd be 2, 4, and 6. The probability of a multiple of 3, well, that's 3 and 6, so that's 2 out of 6. And then the probability of the 2 occurring at the same time, well, it would be actually multiplying the 2 together. Well, 3, 6 times 2 6 would give us 6 over 36, which in reality we can reduce to 1/6. Or if we want to think about it, the probability of the two things, something being even and a multiple of 3, well, the only even multiple of 3 I can think of on a dice is 6, so 1 out of 6. And so now we'll just conduct this calculation. 3 over 6 plus 2/6 is 5/6, minus 1/6 is 4/6, or in this case, 2/3. Question 2, the probability of rolling either an odd number or a number less than 4 when rolling a standard dice. Well, probability of, we'll say odd, or probability of less than 4 means we're looking for the probability of odd plus the probability of less than 4 minus the probability of odd and less than 4. So probability of an odd number on a dice, well, that's 3 out of 6, 1, 3, and 5. Probability of a number less than 4, well, 3, 2, and 1, so 3 out of 6. The probability of an odd number that's also less than 4, well, that would be 1 and 3, so that'd be 2 out of 6. So we'll go ahead and calculate this. We've got 3 plus 3 is 6, so 6 over 6 minus 2/6 is 4/6, which gives us 2/3. And keep in mind, as we go through these, instead of writing or here, I could be using the symbol. All right, so in the last one, suppose you roll 2 standard die. What is the probability that the sum is greater than 9 or even? So the sum is greater than 9 or that the sum would be even. All right, so probability of sum greater than 9 or the sum is even. Well, that means you're looking for the probability that your sum is greater than 9 plus the probability that your sum is even minus the probability that you have sum greater than 9 and even. So the probability that your sum would be greater than 9 when you roll 2 dice, well, there's quite a few of these. Just kind of count them out. In reality, there's There's a total of 6 out of 36 possible ways for this to occur with 2 dice. And then the sum to be even, well, that'd be half of all the possible ways you could get any of the 2 rolls, so that would be 18 out of 36. And then the probability that it's greater than 9 and even. One way to calculate this would be to multiply the 2 probabilities together, or if you want to calculate it out by thinking about it, you can. Greater than 9, but also be even. So possibilities for greater than 9 and even, you've got 5 and 5, 6 and 4, 4 and 6, and then for 12 you've got 6 and 6, so there's 4 options here. So 4 out of 36 possible rolls there. Then you're just going to conduct this to find your probability. Well, in this case, 6 and 18 gives us 24, minus 4 would be 20, so you're looking at 20 over 36, which we can reduce down to 5 out of 9. So the probability of the sum being greater than 9 and this, or the sum being even would be, in this case, 5 out of 9. So about 5 out of 9 times. So the last part of this is the lesson check. So go ahead and try to put together what you saw here. Pause the video, try it on your own, and when you're ready, unpause the video and I'll kind of walk through some of this real quick. So suppose A and B are independent events. What is the probability of A and B if the probability of A and the probability A is 50 and the probability of B is 25? So keep in mind, because they're independent events, we're looking at the probability of A times the probability of B, which we'll turn them into decimals for. And in this case, we're going to get, we multiply that out, we get 0.125, or in this case, 12.5%. Question 2, suppose A and B are mutually exclusive events. What is the probability of A or B if the probability of A is 0.6 and the probability of B is 0.25? Well, because they're mutually exclusive and we're talking about an or situation here, so the probability of A and B occurring at the same time would be just adding the 2 probabilities together, so 0.6 plus 0.25, which gives us 0.85. For 3, suppose A and B are overlapping events. What is the probability of A and B if the probability of A is 1/3, the probability of B is 1/2, and the probability of A and B is 1/5? Okay, in reality, this should be A or B here, because A and B at the same time would be, they can't occur. Essentially, they should be able to occur. Oh, no, they can. They can. I don't know what I'm talking about. All right. So in this case, we're going to go ahead and find the probability of the 2, but they're overlapping events, so we account for the overlap at the end by subtracting it. So we'll take the probability of A plus the probability of B minus the probability of A and B. All right, so A, 1/3 plus B, which is 1/2, minus 1/5. Well, these are fractions, so we need like denominators. In reality, 1/3 would be 3/30, 1/2 would be not 3/30, sorry. It'd be 10/30, so we would have 10/30 here. So let me actually just write these off to the side. We've got 10/30 plus 15/30 minus, in this case, you'd multiply this by 6, so 6/30. And we'd calculate this now that we have like denominators so we can subtract our fractions. And we should get the probability to be 19/30.